Hello and welcome to All Maths Considered. In this short video, we would like to learn how to check the solutions of a quadratic equation in an easy way. Our purpose is to look at the way which uses as easy calculations as possible. So let's say we are in a situation where we have computed some solutions of a quadratic equation. Perhaps we used quadratic formula or completing the square, one of the methods, it doesn't matter. And now we want just to check if the solutions which we found are correct, and we want to do it as fast as possible. So one way to do it would be, of course, just to take these values and substitute them into the equation, just plug them in. That, however, will probably lead to quite some calculations depending on the roots. So let us look at a different way. So in our first example, we have a quadratic equation x squared minus 2x minus 16 equal to 0. The roots, the solutions which we have calculated, are x1, 1 plus square root of 17, and x2 is 1 minus square root of 17. Our check then goes as follows. We calculate the sum of the two solutions and also their product. The sum is very easy to calculate because it's 1 plus square root of 17 plus 1 minus square root of 17 gives 2. The product is also easy to calculate because 1 plus square root of 17 times 1 minus square root of 17. We remember the formula a plus b times a minus b is a squared minus b squared. So this is 1 minus 17, which comes out as minus 16. And now what we check is that in the first case, 2 should be the negative of the second coefficient. And the second, minus 16, should be the third coefficient of our quadratic equation. If they are, then we have calculated them correctly. Now this is a method which works if the first coefficient in our quadratic equation, the leading coefficient, the coefficient of x squared, is 1. So that equation is in reduced form. So if we have reduced form, all we have to do is just to calculate the sum and the product and compare them with the second and the third coefficient, given that the first coefficient is 1. Now, if we were to try to plug it in, if we plug it in, then let's say we want to plug in x1, then we would have 1 plus square root of 17 squared minus 2 times 1 plus square root of 17 minus 16. And then we would have to compute that. We have to take the square and so on. So we'll have calculations. So clearly it's simpler just to calculate the sum and the product. Now let's move on to the second example. And in that case, we have a quadratic equation 4x squared minus 4x minus 27 equal to 0. So that one is not in the reduced form. And so the first coefficient is actually 4. Now, usually, when you have equations like this, the school book will tell us reduce it, divide by 4, and then proceed. Well, if we do so, we will have a fraction, 27 divided by 4. You could do that, but it's easier not to do that, but just to calculate directly by doing the following check. So our check now is, rather than calculating the sum of the two solutions, we calculate the sum times the first coefficient, 4. So that would be 4 times the sum, which comes out to 1. So this is 4. Comparing that to the second coefficient, again, the check is that that should be the negative of the second coefficient. And the same goes for the product. Rather than calculating just the product, x1, x2, we calculate 4 times the product. We take the first coefficient, 4, times the product. Calculating that, and using the same formula, where the sum times the difference of two numbers is the same as the difference of their squares, comes out as square of 1/2, 1/4, minus square root of 7, which is 7, which comes out as 1 minus 28 minus 27. Comparing that to the third coefficient, we see that we are right, and these are the correct solutions. So that's how you do that in the two examples. So in formula, what we need to do is as follows. if we have quadratic equation ax squared plus bx plus c equal to 0 and solutions x1 and x2, we need to do the following checks. We need to check that a times x1 plus x2 is equal to minus b, and a times x1, x2 equal to c. And if these two checks come out all right, then your solutions are correct. And that is a way to check the solutions of a quadratic equation as an alternative to simply plugging them into the equation. That way is much faster.